Okay, so before I do this next problem, I just want to go over binomial expansion. Okay, so binomial expansion is this. If we were to expand a binomial, so for example, a plus b squared, it was going to look like this. It's going to follow the coefficients of Pascal's triangle. So in this case, Pascal's triangle is going to be 1, 2, 1. So that's the second layer of Pascal's triangle. And this a plus b expansion ends up being a squared plus 2ab plus b squared. So 1, 2, 1. And this becomes a shortcut for us to be able to expand binomials of any power. Okay, because if I have an a plus b to the power 3 expansion, I can FOIL it all out and combine all my like terms. But there is a shortcut to this, and I'm going to use this shortcut, so I just want to explain it beforehand. So I have a plus b cubed. It's going to follow the coefficients 1, 3, 3, 1. Okay, so it's going to be a cubed plus 3a squared b plus, so 1, 3, 3, 3ab squared plus b cubed. Okay, so it's going to, and the power is going to descend on the a and increase on the b. So to do this next problem here, I've set up the point at x equals 2 on the curve y equals x cubed. So there's my curve. The point is going to be at x equals 2, y equals 8. So I'm just going to find some point arbitrarily close and call it 2 plus h. Okay, so the y coordinate of that is going to be 2 plus h squared when I plug it into that function. So there's my rise, there's my run. So the difference in these coordinates is going to be my rise. So I get 2 plus h cubed minus 8. That represents my rise. The run is going to be the distance between those 2 points, which is going to be h. Okay, so there's my limit. So I'm going to, this is 0 over 0 right now, which I can't do, but if I can just do a limit as I bring it closer, I'm going to be able to work this out. I just need to get rid of the 0 divide by 0. So I'm going to algebraically get rid of that divide by 0. So I'm going to expand out this cube. So when I expand out this cube, it looks like this. 2 cubed plus 3 times 2 squared h plus 3 times 2h squared plus h cubed. Okay, and just to highlight what I just showed you, there's a 1, 3, 3, 1. Okay, so I'll put the 1 there, and then I'm going to subtract my 8. Okay, so there's my binomial expansion, and I'll divide that by h. So I'll simplify that first before I start canceling things out. Limit as h goes to 0 is going to be 8 plus 12h plus 6h squared plus h cubed minus 8 all over h. Our 8's cancel out. Okay, I also have now my divisor, h, can cancel out with one of each of these factors, so that ends up being squared. Now I've gotten rid of my divide by h, so I get the limit as h goes to 0 of 12 plus 6h plus h squared. Well, that's when I plug in 0, I get 12. So my slope ratio ends up being 12. So this tangent slope at that point is going to be a slope of 12. Okay, it's kind of hard to see